So I'm going to start with a short introduction. Prasad gave a bit of an introduction for me, but I'm going to go ahead and go through my slide anyway. My name is James Latson. I am well, this was an old slide, actually. I am now a senior designer at Altec and have crossed over my 5 years. I am a SolidWorks champion. I am a user group leader. And like Prasad said, as of late last year, earlier this year, I am also a certified SolidWorks expert. A few things personally, I am a motorcycle enthusiast. I am a bit of a coffee connoisseur. I actually roast my own coffee, which is kind of cool. Some people enjoy that. And then I do some photography as well. So we will go ahead and get started. Let me see if I can get there we go. I wanted to be able to see the chat too, to get that up. Okay. So table of contents here. We're going to talk about 4 main things here. The first one we're going to talk about is the sheet metal trinity, mastering the 3 core sheet metal techniques. And then we're going to move on to flattening the curve, unlocking the secrets to flat patterns. Third, we're going to get into geometry gone rogue, taming imported parts for seamless design. And then finally, we are going to think outside the fold, creative solutions using sheet metal features. So we're going to get right into the first of our sheet metal trinity, and that is insert bend. So insert bend is kind of the OG sheet metal feature. You know, we're talking before SolidWorks 2001, introduced in 97. For those that know, SolidWorks was released in 95. So this can tell you just how old this particular feature is. As far as when SolidWorks released, it was only 2 years after the original release that insert bend was added to SolidWorks. Some cool things about insert bend is it can be used for cylindrical and conical shapes. And it is really powerful when dealing with imported geometry, which we will get to in our geometry gone rogue portion of this presentation. And then some drawbacks for insert bend is it does need uniform wall thickness, and it doesn't particularly like it if you have radius in your part already. Sharp corners work best with it. So the way insert bend works is you start from a thin feature solid body. And like I said, it needs uniform wall thickness. You choose a fixed face and ripped edges, and then you end with a sheet metal part that can be flattened. So what I'm going to do here is I'm going to go ahead and hop into SolidWorks and show how insert bend works. So as you can see here, I have a solid body, and all I did was I shelled it and deleted the top and the front face. So now this is a solid model. You can see there is no sheet metal feature in the model tree, but it is, you know, vaguely similar. It looks kind of like it could be a sheet metal part, right? So that's what we're going to do is we're going to use insert bend to turn this into a sheet metal part. So we'll come up to the sheet metal tab. If you don't have the sheet metal tab, if you right click on any of the tabs up here, you can come to toolbars, tabs, and you can turn sheet metal on. Should be right there. But all the way down at the end of the sheet metal tab is our insert bend command. So we're going to click that insert bend command. And what it's going to do is it's going to ask us to provide a fixed face. So in this case, we're just going to choose this bottom face here, because to me, it makes sense that everything unfolds around that kind of bottom middle face, right? And then what we're going to do is we're going to choose rip parameters. And I'll just drop that down. There we go. We're going to click in this rip parameters box. And what we're going to do here is think about which of these corners are going to be bends and which of them we need SolidWorks to rip. We need SolidWorks to remove material because it's not going to be a bend, right? So it makes sense to me that the adjacent bends to the highlighted face, and then adjacent from there will be bends, and then maybe that one back there in the back will be a bend. So that means this vertical face, this horizontal face, this vertical face, and then same on the other side will all be rips, right? So we don't want bends on those 6 edges back there. So now if I just hit my green check mark, I'm going to get a quick pop-up that just says auto relief cuts were made. And when I click OK, you can now see I have a sheet metal part, and you can see it ripped these back corners, right? And then it applied bends to all of my edges that I did not apply rip to. And like I said before, the whole point in this is it can be flattened. So I'm going to hop back into this one more time just to show you a quick feature in this insert bend command. I'm going to do that one more time, and I'm going to choose my fixed face. I'm going to choose my ripped edges. And as I'm choosing this, you can see these yellow arrows popping up. Each one of these yellow arrows, or each one of these highlighted edges that I'm choosing, has these yellow arrows on it. And what this is it's giving you the option to extend one of the faces. So in the instance right now where every single edge has 2 yellow arrows, it means that neither face is going to overlap one or the other. But let's say I want this back like T-shaped face to overlap the side flanges. So what I'm going to do is I'm going to hit that yellow arrow saying cut this direction, right? And I want to do it on all 6 of these. And you can see as soon as I get done with this, I'm going to hit my green check mark. And now you're going to see that this face, that back face, well, okay, that back face there is overlapping the rest of my flanges, right? So that's a quick little insert bend tutorial there for you. And we will touch on it again once we get into our geometry gone rogue, all about imported geometry. But for now, let's hop back into the presentation and let's move on to our next feature of our sheet metal trinity. So this is kind of a group of features here, and this is the what I call the base flange and friends portion of this presentation. Anyone who has any knowledge of SolidWorks sheet metal is most likely going to know what base flange tab is, right? This is our like de facto standard sheet metal feature, as well as some of these other ones like edge flange, miter flange, and jog. But I feel like there's a few things within these features that can be overlooked, or some tools, or random small checkboxes within these tools that are very powerful that people tend to not know what they do or don't know that they're there. So that's what I'm going to talk about here, right? And then just like with insert bend, we're going to start from a thin feature sketch. We are going to declare material, bend radius, K factor, all that good stuff, get a preview of it. And then ultimately, like I said, the solution will be ending with a sheet metal part, and that can be flattened, right? So I'm going to go back one page just so I can keep an eye on that, because I'm going to need that on my second screen here in a second. If I can get it pulled back up. Well, shoot. There we go. Okay, and then I am going to hop back into SolidWorks and kind of show you some of this. So some of these cool things that we can do in the base flange and friends section. So I have this pretty complex sheet metal part here, and the real thing with this one is I just wanted to add a bunch of things in here that I would need just to kind of give you an idea of what some of these features can do. But for now, what I'm going to do is I'm going to roll this bar back, and I'm going to just start with the base flange, right? So like I said, in this base flange, we started with a thin feature sketch, and you can see my sketch here. It's just 3 lines. It's not a solid model like I did with the insert bend. And I set, some material thickness, and I set a bend radius. And then once we created this part, I can come up here and I can set a material. I can come into sheet metal feature and edit it, and I can set a gauge table if the company you're working for has specific gauge tables. So all that should be pretty standard sheet metal stuff. If you've done anything in sheet metal, you should know those things, right? But if I come up here to edge flange and we throw an edge flange on this edge right here, there's a couple things in this edge flange feature here that I want to touch on. And I'm going to hit the space bar and give a normal 2 here so we can kind of see this profile. And I'm going to zoom in a little bit here. So the first thing I want to talk about is the flange position when it comes to edge flange. And it's going to be located down here towards the bottom of this toolbar. And it's these 5 buttons here. And the main 3 I'm going to talk about are these first 3. So the one that I have currently set is the one in the middle here, which is bend outside. And you can see that what it's doing is it is adding material to our existing leg of that original sheet metal part. Right. So you may not know this, but I can show you my original leg is 2 inches long. Right. So if I come back into this edge flange and I add that edge flange and I hit the green check mark, you can see that what this did is it took the bend radius, which I can highlight it and I can look down here, 0.1345, and then the material thickness, which is 1/8 inch, and it added that to the overall length of this leg. So now if I measure this, you can see I am 2.2595, right? So that is what the entire bend outside does on the flange position. So let me show you the difference here, right? So, and you can see it's completely outside of that leg. But if I go back one, what it's going to do is it's going to absorb that bend into the existing leg, but then it's going to keep the material thickness outside. So like I said, the material thickness is an eighth of an inch. So now if I hit the green check mark and I measure this again, you can see that now we have 2 1/8 inch, which makes sense, right? Let me go one more time into this edit. We'll go normal 2 again, and then I'm going to choose the last one, which is going to be material inside. And you can see what it's doing. It is absorbing some of the leg that was there, and it is keeping that 2 inch basically. So my 2 inch that I set here in the original sketch, you can see that face to face, I now still have exactly 2 inches. So that is the flange position. So let me hop back into this editing this edge flange one more time. I can't talk this morning. Sorry about that. And I'm going to show you another cool thing that we can do with the edge flange. So let's say maybe we don't want this flange to be the entire width, right? So this this part is 6 inches long, and I could hit that measure button so you can see it. This part is 6 inches wide. Let me say it that way. So maybe we don't want that to be an entire 6 inches. Maybe we want this. Maybe we don't want it on this back like 2 inches, right? So something we can do is we can come up here and we can choose the edge that we want to edit, and we can hit edit flange profile. And what this is going to do is it's going to bring us into a sketch. And I'm going to Control 8 just to go normal 2 and move this up out of the way. And you can see that this is the sketch that it automatically gave us for that edge flange. So like I said, maybe we don't want it to go all the way to the end. And something cool that we can do here, you can see that these 2 lines on the end, they are black, so they are showing like they are fully defined. But the cool thing about this is they have what I like to call soft relations, which just means that they are defined until you don't need them to be, right? So a simple click and drag, you can now see that this line is blue, and I have moved it and made it to where it is not fully defined anymore. So I'm gonna grab a dimension, and let's say I want this offset, 1.5 inches there. So now when I hit this finish button, you can see that that's exactly what it did. So instead of editing sketch this way, which is a common way to edit a sketch, know that you can edit your flange profiles within the edge flange feature before you ever create that feature. Something else cool about this is, maybe we don't want it to be 90 degrees, right? Maybe we need this to be angled. So I can click here, I can delete that vertical relation, and now I can drag that in, right? So now I have and I am missing my, where did it go? There it is. I moved it. There we go. Hit that finish button, and now I have a angled edge flange as well. And then the last one that I want to talk about in the edge flange, let me get back in here one more time, is down here below flange position, and it is the offset check mark. So let's say we know that this leg is 2 inches long, and we know that we want the overall height from top to bottom of the flange. Maybe we want it to be 6 inches, right? But we don't want to extend the length of the leg because we cut this back and we don't want to have to cut later on. So you can do that all in this edge flange feature as well. You just hit this offset button here, and you can, so now what it's doing is it is going to add material, and you can kind of see where it's added some already. It's going to add material before it makes that edge flange. And we can set a dimension to that, right? So we knew that this leg was 2 inches long. So let's say we want to add an extra 4 inches just to get that 6 inch. Now, with a couple clicks, you can see that I have exactly a 6 inch leg. Okay. Prasad, I do not have the chat up at the moment. So if someone asks a question that's relevant, stop me. I don't mind answering the questions as we go.
Absolutely.
I will pull it back up here in a second. I needed my my second screen to keep me on track.
Sure.
Okay, so the next thing I'm going to hop into is the mitered flange. Particularly, I want to show you a quick trick of if you select an edge when you get into your mitered flange feature, if you select the proper edge, what it's going to do is it's going to automatically create a plane for you and start a sketch like it needs or like it's supposed to, which I thought was kind of a cool feature. But when I click the mitered flange feature, and I'm going to do that again, did a little quick. It's up here in the sheet metal tab. Click mitered flange. And just like any other edge flange or any other SolidWorks feature, if you haven't already pre-selected something, it's going to ask you to choose a face or a plane or something to sketch on. But what we can do, and if you remember that part that we had earlier before I rolled the bar back, there was this kind of like mitered flange, weird angle on the front of this part that kind of followed all these adjacent edges. We're just going to remake that, right? So what I'm going to do is I'm going to choose the edge here that I want to start with. And as soon as I choose it, you're going to see it took me directly into a sketch. Now, if I were to exit the sketch, you can see that what I was talking about is it went ahead and created the plane that I needed for that sketch. So this is a cool little tip of like, don't worry about choosing the exact face that you want to sketch on. All you have to do is click your mitered flange and just choose the edge that you want to start with, and it's going to automatically make that plane for you. So I'm just going to go ahead and draw something in here real quick. I'm not going to worry about fully defining it. Don't tell Too Tall Toby on me, you know. And then when I hit this exit sketch, you can see that it's going to go ahead and give me the preview, and I can go ahead and choose my additional edges that I want this as. And just like other edge flange and other sheet metal features, you know, we have stuff like gap distance. Maybe I want that gap distance to be 1/8 of an inch. You can see where it added that gap distance. And then also I do also have flange position in mitered flange, just like I had in edge flange. So maybe I want, you know, the entire bend outside. You know, I don't want that to take some of my bend. So there we go. There's our mitered flange. And then the last thing that I want to talk about is the jog feature. And what I'm going to do here is I'm going to come back into this original edge flange, and I'm going to take that offset off, and I am going to just increase the length of this flange just so I can show you the jog feature. So the way the jog feature works is it ideally you start with a edge flange that you have already created. Right, so I created this edge flange. And let me actually go back in. That was the wrong feature. Let me actually go back in and set an exact length on this just so I can show something later on. So I set this edge flange to exactly 4 inches. So from outside to outside is going to be exactly 4 inches. So the way jog works is kind of like mitered flange. I'm going to click it, and it's going to ask me for a planar face to sketch on. So I'm just going to choose this top face. And just for purposes of making this quick, I'm not going to do anything fancy. I'm just going to draw a straight line. Doesn't have to end on the end points of this flange. Honestly, I think I could probably, shorten it like this, and it would work as well. It doesn't have to be horizontal or vertical. It could be at an angle as well. But for purposes of this, I am going to go ahead and, I'm going to go ahead and make it, shouldn't have been horizontal, should have been vertical. And there we go. Oh, well, now it's going the opposite way. Cool. Okay. So now I have my sketch where I want my jog to be. And all I'm going to do is I'm going to exit sketch, and it's going to automatically take me into the jog feature. And just like any other sheet metal feature, it's going to start by asking you for a fixed face, or just like a lot of other sheet metal features. So in this case, I know that this edge flange comes off, and I want it to jog up and then back over. So what I'm going to do is I'm going to choose the right side of my line as my fixed face, and you can see it's going to automatically start giving me a preview. So the thing that I really want to point out in the jog feature is this little checkbox right here, which is fixed projected length. So with it checked like it is right now, what this is doing is it is projecting this original edge flange up, however much I told it to project it up, right? But it is projecting it up, and it is adding material to keep my original, 4 inches, right? So if I hit the green check mark and I measure this now, you can see that I have exactly 4 inches still, right? But let's say I created that edge flange, and I created it knowing that I wanted it to be 4 inches in the flat. I didn't want it to be 4 inches once it was formed. So what I can do is I can unselect that fixed projected length, and you can kind of see what it did. Let me zoom in. Let me click it again. There is longer, there it's shorter. So what that did is it took the existing material and applied the jog to that existing material without adding any extra material. So now if I come in here and I measure this again, you can see I'm now, almost a 1/4 inch less than 4 inches where I started. Okay, so that is the jog feature, and that's going to bring us to the end of our base flange and flange section. So what I'm going to do is I'm going to go ahead and delete what I've done, and I'm going to bring all of this back just because I'm going to use this part later on.
James, we have a few questions.
Yeah, let me get the chat up, and I will see if I can answer them.
So one is Syed Asadullah. He's asking, can you elaborate a bit about God's table?
About what?
God's table.
Oh, gauge tables.
Yeah.
Yeah, okay. I can definitely elaborate a little bit. So gauge tables, let me get SolidWorks back up. Okay. Gauge tables are located, you can get to them by editing your sheet metal feature. And the company I work for uses gauge tables. And really what gauge tables is so when you are dealing with sheet metal parts, materials, when you bend sheet metal, as you bend it, certain parts of the material shrinks and certain parts of the material stretches, right? So what gauge tables basically are is it is a table of thicknesses and bend radiuses and K factors that are previously set based on knowledge where you or your shop or whoever you use to fabricate your parts has gone through and done testing to figure out exactly how the material that you have acts when load and force is added to it to bend it, right? So for instance, if I come in here to this steel gauge table that my company has, and it's going to take it a second to load. Okay. So now if I come in here and I choose, let's say 16 gauge, you can see that my company has already set 16 gauge to have a default bend radius of a little under a 16th of an inch and a K factor of 0.4. Right. So if I come in here and I say, let me do 7 gauge, you can see that my K factor stayed the same, but my bend radius now went up 2/4 of an inch. So that's all gauge tables are, is it's a way to predefine what your bend radius needs to be based on your fabrication shop's capabilities.
We have
makes sense.
More question from Arun Kumar. How can we determine the appropriate bending allowances for laser cut sheet metal parts?
So that is very, very on point with what I was just talking about with gauge tables. The way that is done is testing, right? Any fabrication shop that has been around for any period of time is most likely going to have all of that already figured out, right? So if you are doing work for a company, maybe you are a contracted company and you, or a contracted employee, and you are sending material to a fab shop, I would reach out to that fab shop and figure out what their bend allowances and K factors and stuff like that are. If I remember right, and maybe Prasad, maybe you know this and or can confirm, the default, like in SolidWorks, default K factor is, I think it is actually like 0.4, and that's a good place to start. But there's definitely a bit of it's a bit of a science, and it's a bit of I'm not going to say guessing. It's not quite guessing. It's educated guessing, right? That's the best way to put it. Is so sheet metal definitely has a bit of a tolerance. And it also depends on your sheet metal provider, like where you get your sheet metal from. That will determine how the metal bends, right? Certain suppliers metal bends differently than others. So like I said, it's definitely good if you're working with a company to fabricate components. Definitely work with them to figure out what all of your K factors and bend allowances are. And I did see explain K factor.
Yes.
K factor is a hard one to explain. It's definitely not. And I think my mouse just died. Oh, wait. Okay, there we go. It just lagged for a second. Okay. So K factor is basically, let me get in here. So if K factor is it determines how the sheet metal parts bend. And actually, I think I have some documentation. Instead of me trying to show it and stumble through the explanation, I am going to find, there should be a printout that I have that I can show. Quick picture to kind of explain what K factor actually is. Okay, so I'm going to pull this over, and Prasad, tell me if you can see this.
Yeah, we can see the PDF.
Okay, so in every sheet metal part, there is a center line, and you can see the dotted line here. There's a center line that exists, and this is what I was talking about in the beginning of the gauge tables feature, or in talking about gauge tables, is certain parts of the material will shrink and contract, and others will expand. So in this particular bend that you can see on the screen, the material on the inside of this bend is going to shrink and contract, and the material on the outside is going to expand. So what K factor is this T here, this T dimension. It is, so 0.4 means that it is 0.4 of the, or 40% of the way through the material is that center line. So, like I said, it's really something that you need to work with your fabrication shop to determine what the ideal K factor is for your material and for your for their like press brakes, their machines that are bending the parts. I hope that explains it. I'm
Yes.
not as versed in the actual fabrication of sheet metal parts as I would like to be. I feel like I may have explained it pretty good.
You have explained it very well.
Okay.
Shall we
Well,
take
cool.
2 more questions?
What's up?
Shall we take 2 more questions? We
Yep.
have more questions coming. So one is from Johannes. Is there any universal gauge table, or it's based on the company?
It's definitely based on the company. I think SolidWorks has some default gauge tables that they give you, which
Yes.
is just like I said, default K factor is 0.4. So that's what it's going to give you. And there is kind of a universal rule in sheet metal of your bend radius. So your radius on the inside of the bend. So you can see in this case, I am 0.1345. Your bend radius should never be smaller than your material thickness. So for 1/8 inch, I don't want 16th inch bend radius. That's not going to work. So that's most likely what the like default gauge tables that SolidWorks is going to give you is going to follow. It's going to follow some similar rule where it's going to give you a average of probably 0.4 K factor. And each material, the bend radius is going to be slightly larger than the material thickness. But yes, there should be just like default gauge tables in SolidWorks.
There's similar question. I think you've already explained it, but the question is from Muhammad: how can I calculate the R, means the radius, bend radius, when the plates, through experience or through the catalog?
I'm not sure I understand.
Yeah, maybe the R is the bend radius. Is it, Muhammad?
I'm trying to see if I can find the question so I can read it.
I'll just wait. Yeah, here it is. I'll just copy paste it in the Q&A so that it's easier. Yeah.
Okay. I'm not seeing where you copied it. Okay. No, yeah, I'm not seeing where you pasted it into the Q&A.
It's in the queue as well. He just posted in AR. Okay, it's the bend radius. How
Okay.
can you calculate the bend radius? That's what he's asking.
Okay. So yeah. Okay. So like I said, there is a universal rule in sheet metal, which is your bend radius should never be smaller than your material thickness. But really, the bend radius that you use for each material is going to be determined based on the fabrication shop's capabilities. So if you're at a press brake, depending on what tooling that press brake has, will depend on what your your bend radius is ultimately. As far as designing sheet metal parts, I would tend to lean towards whatever the default bend radius is that SolidWorks gauge tables gives you. If you're just trying to design parts, and then as far as like and everybody is very interested in certification vouchers. As far as the certification goes, when you get into the certification, it's going to tell you exactly what bend radius to apply. It's not going to be something that you just have to know based on what the material thickness is, right? It's going to tell you exactly what it is.
And
Cool.
one last question.
Yep.
How can we distort and bend a sheet metal to as we like? Basically, he's asking how can he use sheet metal to basically bend and create what he wants. It's very
So that's really where my edge flange and flange stuff gets into, right? All of these sheet metal features you're going to use to make, some crazy part like I have here, right? I think that kind of answers the question.
Yes. Yes.
Yep. Okay. Well, cool. I'm gonna keep going and
Yes.
stop me as you need to, Prasad.
Sure. Sure.
Okay. Presentation there. Okay. Cool. So the next thing that I am going to talk about is the final piece of our sheet metal trinity, which is convert to sheet metal. And I'm gonna try to move through these a little bit. We spent a lot of time on, which is fine. Like I don't have any issue with it, but just try to respect everyone's time. I'm gonna try to move through this one a little quick. If you have questions, though, go ahead and stop me. So convert to sheet metal allows you to convert a solid body to sheet metal parts. And then sheet metal features like the edge flange and all the base flange and flange that I just talked about can then be added once it's converted. Cool thing about convert to sheet metal, it is very powerful for complex angles and can be used for multi-body sheet metal parts. And then a cool thing once we get into the imported geometry part of it is it does not need uniform wall thickness like insert bend does. So convert to sheet metal, you're going to start from a solid body. You're going to choose a fixed face and bend edges, and you're going to end with a sheet metal part that can be flattened, right? So hop back into SolidWorks one more time and get my part open. So here I have a solid model that you can see has multiple different draft angles. And if you've never done sheet metal part or sheet metal before, trust me in saying trying to do this as with just edge flange and other features like that would not be very easy. The fact that these all draft at a different angle would make that very difficult. But luckily, we have convert to sheet metal, right? So what I'm going to do is I'm going to hit this convert to sheet metal button, and just like insert bend, it is going to ask me for a fixed face. And again, to me, it makes the most sense to have the kind of bottom-most face as the fixed face. Then what we're going to do here is instead of choosing the edges to rip, like we did in insert bend, we're going to actually choose the edges that we want to become bends. But you have to watch the order that you choose these edges. The order of operation of this definitely matters. So from this bottom face that is highlighted yellow there, it makes sense to me for like this side face, this angled face, the back face, and this side face over here to all be flanges that come off of that. So that's what I'm going to do is I'm going to choose these 4 edges down here. And you can see as I choose them, it automatically shows a preview of those flanges. But so like what I was saying about order of operations, if I weren't to choose these side ones here, and I were to choose instead this edge here, you can see that is where it is going to bend. It applies the bend to that edge instead of this bottom edge. To me, that doesn't make much sense, so I'm just going to go back to the way I had it. And then with a green check mark here, we are going to have a sheet metal part. And apparently I forgot the last edge. There we go. Right there, and one more edge. There we go. So now we have a sheet metal part. And this sheet metal part can now have things like edge flange applied to it, right? So I can choose edge flange, and I can drag an edge flange off of there. Well, if I wouldn't hit escape too many times, I drag an edge flange, and I can make edge flanges off of it. I could add a little cut down here if I wanted, or, maybe I want this to actually be a multi-body part, right? Maybe it makes sense for these 4 faces to be a part, and then for these 2 to be an own separate part. So basically, let's get rid of that bend there. I'm going to show you how to do that as well. So I'm going to Control Z. I'm going to undo and start back at the beginning. I'm going to come right back in to convert to sheet metal. And again, I'm going to choose a fixed face. And then, like I said, let's say we only want these 3 edges here as bends, right? So I'm going to hit this little keep body button here. And what that's going to do is it's going to keep my original, and I'm going to reverse thickness as well. So it's going to keep my original solid model. And let's actually take and let's plot, let's see if I can just cut that material. No, that didn't work. Okay, Control Z. Anyway, I was going to try to apply an appearance to this just so I can show it different. Oh, my color is out. Painted. There we go. We'll just choose like red. I'm going to apply it to body. So now we can see that the red is the original body that I started with, right? So too far. That is my original body. And what I've done is I've added a sheet metal part and I've told it to keep the body. That way I can go in and make this second part. So now if I come in and I say convert to sheet metal again, I can say, okay, this is going to be my fixed face this time. And then my bend edges, I only have one, is going to be here. And then when I hit the green check mark, you can see I now have the full part and it needs a little bit of cleanup, right? Because it's not going to automatically apply corner release for me. But now I have 2 sheet metal parts. I have one there, and then I have one here as well. So the idea of that is if you have a very complex shape that you need to make a sheet metal part out of, you can keep body and then make each individual part. And then what you would do is you would just save this part as its own part, and then you can assemble it in an assembly later on. Okay, so that is convert to sheet metal. So now let's move on to the next portion of our presentation, which is flattening the curve, all about flat patterns. So the first thing I want to talk about when we get into flat patterns is the first term I want to talk about is what was actually coined by Toby Snars. He runs the Too Tall Toby YouTube channel. If you've ever seen it, if you've never seen it, I would definitely recommend it. Toby has a ton of material out there, a ton of knowledge, but he coined this term that he calls the sheet metal sandwich. And before we really get into it, I do want to talk about one more thing, which is just exactly what the flatten button does on the sheet metal bar, on the sheet metal toolbar. So you saw me use it earlier. You click it, it makes the part flat, and you click it again, and it forms it back. So the flatten button, simply put, just unsuppresses the flat pattern feature in the model tree. What it doesn't do is it does not create a flat pattern configuration. And we will get into how to create a correct way to create the flat pattern configuration here in a second. But let's get back to our sheet metal sandwich, right? The big thing to note is do not work in the flattened state. And you can see at this picture of the model tree, if you think about a sandwich, right, you have 2 pieces of bread and you have fill-ins in between. So your sheet metal feature and your flat pattern feature are your pieces of bread in this sheet metal sandwich. Everything else should fall in between those. Everything else is just fillings in the sandwich. So your edge flanges, your jogs, your miters, your hems, all of that should fall between your sheet metal and your flat pattern feature. And I will give a quick example of what happens if you do not do that, right? So I'm gonna come back to this part here, and you can see again, here's my flat pattern, and here is my sheet metal. Everything has fallen in between those 2 features. So when I flatten this, everything flattens kind of like I would think it would, right? So if I were to come in here and I were to sketch and draw a circle on this top face here, right? And S key, cut, and cut it down. Let's just unlink the thickness and let's just drag it down a little bit. You can see that it cut it on the top face, and on the side face, it just kind of looks like a square because it's just, if we were to look at this straight on, that's kind of how the cut cuts into it, right? Let's say what if we want this cut, this circular cut to extend over the bend, right? It may be easy to, okay, well, let me just, Tom is like, well, let me just hit this flatten button, and then I can do the same thing, and I can sketch, and I can draw me a circle, okay? And then when I cut it through, it gives me what I kind of wanted, which is the radius of that circle extends past the bend. But the issue now is that our cut extrude that we just did falls outside of our sheet metal sandwich. So now we have a piece of cheese underneath our bread. We don't want that, right? And the reason we don't want that is because if we unclick this flatten, you can see that it now suppressed that cut. And there's no way to unsuppress it without unsuppressing the flat pattern. So the correct way to do this, if you need something like a circular cut that extends over the bend, instead of using this flatten button, use the two buttons directly above it, which is unfold and fold. So what I'm going to do is I'm going to start with unfold. And like a lot of other sheet metal features, you're going to start by choosing a fixed face. So I'm going to say, okay, I want this face fixed. And then I want to unfold. Really, I only need to unfold this bend here because that's where my circular cutout is going to go. And when I hit the green check mark, you can see that's what it does. It just unfolds the one bend. So now I can come in here and I can do the same thing. I can sketch a circle and I can cut it all the way through. And then I can come back up here, fold, collect all bends, green check mark. And now I have that cut that is applied the way I want it across the bend, but it shows up in the formed and in the flattened configurations, right? So that is the correct way to do cuts across bends. And the key takeaway there is do not work in the flattened state, right? Never want to work with the flat pattern unsuppressed. So the next thing I want to talk about in flat patterns is, I referred to that flat pattern configuration. The flatten button does not make the flat pattern configuration. But how do I make it, right? And the easiest way to do this is to just let SolidWorks make it for you. Don't make it on your own. And there's a reason for that. But the easiest way to create it is just come up to new and hit make drawing from part. Even if you don't need the drawing, even if you don't need it, once it makes it, you can close it and delete it. You don't need it ever again. But what it does is it creates a flat pattern configuration for you. And if you come to the configurations tab, you can see what it did is it created a derived configuration. And I guess I've been kind of pointing with my cursor. Prasad, you can see my cursor, right?
Yes, we can.
Okay,
yes.
Okay. I've been using it the whole time, and I was hoping I should have asked earlier. But anyway, in this second screenshot here, you can see that the default sheet metal flat pattern configuration is inset from the default, which means it's a derived configuration. That is what we want, right? And then the unique naming convention as well, which is that default SM-flat-pattern. That is something that we need because it is going to give us extra functionality when it comes to, the flat pattern in our prints. So if you are actually doing prints, doing it the proper way gives you extra functionality. And I will show this real quick as well. So like I said, if I come to configuration tab, I currently do not have any configurations. I do not have a flat pattern configuration, right? So if I come up here to new and make drawing from part, I'm just going to choose a drawing size, and it's going to create me a drawing. But like I said, if I don't need this drawing, I'm just going to close it and don't save. And what that did is it created a derived configuration for that flat pattern. So I can double click it and make it active, and you can see there's my flat pattern. And then I double click default and it goes back to the formed, right? So let me do this one more time. Let me go, actually, before I do that, I'm gonna do it the wrong way, right? I'm gonna come up here and I'm gonna right click and I'm gonna say add configuration. And I'm just gonna call this flat pattern. I can't spell, P-A-T-T-E-R, wow, T-T-E-R-N, okay. Flat pattern and hit the green check mark. So now, okay, it didn't automatically flatten it, but I can fix that, right? I can come in here and I can unsuppress the flat pattern feature in that flat pattern configuration that I just created. So now I go default, it's formed, and I go flat pattern, the one that I created, again, not right. And you can see that it works the same. Default configure or default flat pattern, I make it active, it's flat, and I choose my new one and it's flat as well. But if I come back to the drawing, and I'll show you why we don't want to do this, because we lose some functionality here, right? So if I choose this flat pattern, I drag it over into my part. Let's make it a little bigger so I can see it a little better. Let's go 1 to 2. Oh, okay, maybe. Want me to do another, okay. Now we can change that to, let's go 1 to 4. Okay, that's a little better. Okay, so in this feature, if I click it, it's going to populate over here in our feature tree. And you can see that the configuration that it is utilizing is the like flat pattern configuration that I created, right? If I choose that one, you can see all of my bin notes and stuff go away. And I lose functionality of like being able to edit all that stuff, right? But if I come in here and I go back to my configuration the way that I wanted it, the way that it should have been created, you can see all my bin notes come back. And now I can, I can toggle the bin notes on and off. I can toggle the bin lines on and off as well. And then I can, this really gives me the functionality that gives the fab shop what they need. So I can come in here and I can add dimensions now. And they know that I'm clicking wrong keys, my bad. They know that this flange is the center of this bend is 1.89, and it is a bend up at 90 degrees, right? But if I don't have that information, I'm going to have to try to tell the shop some other way, maybe I come in here and I just add a note, but that's just extra work on myself. Why would I do that when I can just let SolidWorks do it for me? Okay, I keep trying to hit my escape key and I hit tilde instead. So that's what those pop-ups are. I just hit the wrong key. Okay, so let's move on a little bit to the next portion of our flat pattern stuff. So editing flat patterns. There's 3 main things here that I want to show you. The first is fixed face, which is a tool that you need to know where it is. For some reason, if your flat pattern or if your part does not unfold the way you think it should, merge faces, it just makes for easy exporting of DXF to DWG. So if you're exporting something to a fab shop. And then the last one is corner treatment for when your corners look differently in the formed view than it does in the flat view. So I'm going to go right back to the part that I've been working on for a second. And I'm already in this flat pattern here. So I'm going to come back to default. And I'm going to go ahead and just delete some of these. I need to, wrong button. I need to close that print because I don't need it anymore. And then I can delete these extra configurations that I don't need. Okay. So I'm going to edit the flat pattern real quick and change something and then explain what I changed and why I changed it. So the first portion of this editing flat patterns is fixed face. And what I meant by for when your flat pattern is unfolding in a weird way is if you think about this part, when I hit the flatten button, to me, this makes sense. The highlighted face makes sense to be the face that stays stationary. everything should unfold out around it, right? But now that I went and changed that fixed face, you can see when I hit the flatten button, it doesn't do that. So this face here is now the fixed face. And then now that I have it highlighted, when I go back to form, you can see it never moved, right? It stays exactly where it was. So like I just showed very quickly, I'll show a little slower. The way to fix this is come into the flat pattern, edit feature, and then it chooses a face, and you can clear selections, choose the face that you actually want to be the fixed face. And now when you flatten it, it should unfold kind of the way that makes the most sense. So typically, if you were doing just like 90-degree parts, all of your stuff is horizontal and vertical, you're probably never going to see the instance of like, oh, it chose a face that doesn't make sense. But when it really comes into play is if you have a part that is it's angled from the start. So I'm going to choose my front plane here, and I'm going to say maybe my part looks like this, right? Horizontal, and then we'll do one more line down here. So maybe this is my sheet metal part, and I do base flange, and I drag it out like this, and I create that part, right? So now if I hit this flat pattern, to me, it doesn't make as much sense for the face that to stay stationary to be this angled face. It makes more sense for a horizontal face to be stationary. But you can see that when I hit the flatten button, it's not the way it is. So that's how you would fix it. You would, again, right-click, edit feature, clear selections, choose the face you actually want to be fixed, and now it flattens, kind of what makes a little more sense, right? So editing flat patterns, merge faces, the next topic here. So when I hit this flat pattern button, you can see that it technically has on this flat face here that is up, it has 1, 2, 3, 4, 5 faces. So if I were to like try to export this, if I were to right click, export DXF DWG, and just say part 4 is fine, it's going to, in order to export this entire part, you can see where it automatically just chose the face that I had highlighted. So I could either, click multiple faces, or let me do that one more time, right click, export. Or the other solution was click this sheet metal button here. And then it's like, okay, this is sheet metal. I need to get the whole part. But something that you can do just to kind of negate a few clicks is when you edit your flat pattern, you can come up here and you can say merge faces. And then when you get into that flat pattern, it's going to automatically just make it one face. And you can see my bend lines are still there, right? I can still unflatten, and you can still see my bend radiuses. But it makes it a little easier if you are constantly exporting DXF. If you just go ahead and set that once, then everything that you make will automatically be easy to just right-click, export, save, and then it automatically chooses the face you need. And I can hit the green check mark, and you can see there's the entire part. So I'm going to hit cancel because I don't actually need that, and I will move on. So the last one that I want to talk about is corner treatment. So you can see in this pretty complex part, there are multiple corners, here and there, that SolidWorks applied a corner treatment for me. SolidWorks was like, hey, we know that in sheet metal, something needs to be removed for this corner to make sense, because I have 2 bends on adjacent flanges, right? But sometimes you will notice, and I will again go and just change something really quick and then explain it after. You can see this corner here looks like it does in the form, but when I hit flatten now, you can see, and it did not, what did it do? Okay, well, it's not doing like I wanted it to. Let's see. Let's roll this back. Let's do this one more time. And I'm just going to add a edge flange just to explain what I wanted to do. And if we choose that other flange, other edge. Okay, so corner treatment. So it applies my corner here. And if I it's going to make a liar out of me, isn't it? Why is that not working? So typically when you have the corner treatment not checked, what it's going to do is it is going to, in the flat pattern, it is going to look different than what it does here. So when I hit this flat pattern button, instead of being this very nice 90-degree cut, and I will swap back to the slideshow real quick because I have an example of it. It is going to look like this bottom right picture here, and it is going to have just like a straight V cut, and then when you form it, it adds that like nice corner treatment. For some reason, SolidWorks is being a little finicky for me and not showing me what I know it is supposed to show. But if you ever see those corners on the flat pattern that don't look right, it doesn't look the same as your formed corners, know that right-click the flat pattern, edit feature, turn your corner treatment on, and it should fix that issue. Okay, well, it's always fun doing live SolidWorks because something always doesn't work like it's supposed to. But anyway, we're going to get out of flat patterns. We're going to move on to our geometry gone rogue section here. The first thing I want to tell you is if you are on a consistent basis taking imported geometry and making sheet metal parts out of it, the big thing that you need to know is turn this 3D interconnect off. Basically, 3D interconnect allows you to use external CAD files like imported geometry in SolidWorks while keeping things. So if you have a supplier that is giving you a imported geometry model and they have some like internal external references in there, by having this 3D Connect on, if they make changes, it should trickle down to the model that you have. But if you are taking imported geometry and you're making sheet metal parts out of it for your company, then you definitely want this off because it's going to make your life very hard. With that said, when it comes to imported geometry, there's two main questions that you want to ask before you start making sheet metal parts out of it. The first one is, does the imported part have uniform wall thickness? And then the second one being, does the part have existing bends? Are there radiuses in the corner already? So in the first example, if the wall thickness is uniform, then to me, the insert bend command is the way to go. If for some reason the wall thickness is not uniform, then convert to sheet metal is the ideal solution here. And then if you get an imported part and the supplier that you got it from for some reason decided, oh yeah, I'm going to go ahead and add, radiuses to make this look more like a sheet metal part, then I'm going to show you not technically a sheet metal feature. It is technically part of the, it's probably part of surfacing or, what is that other toolbar? Anyway, it used a lot in surfacing, but it's the delete face command. And I think it can be very powerful in junction with our sheet metal features when it comes to converting imported geometry to sheet metal. So let's hop into SolidWorks one more time, and I will open a imported part. So number 4 here. So you can see this looks like a sheet metal part, but you can see in the model tree there are no sheet metal features. And I can a quick look, I can surmise that it looks like all of my wall thicknesses are the same. And I can come here and check it, right? That's 1/8 inch. This one over here is 1/8 inch. You know, this one over here is 1/8 inch. So we can check that. And then once we determine that all of our wall thickness is the same, we know, okay, the best possible solution here to make this a sheet metal part would be our insert bends command. And it's very simple. You hit the insert bends command, you choose a fixed face, you choose your bend radius. And again, remember, bend radius should never be less than our material thickness. And what insert bends does is it's going to look at what the thickness is of this part already, and that's what it's going to give a sheet metal thickness to. So I looked earlier, and this sheet metal part is 1/8 inch thick. So all I have to do now is hit my green check mark, and you can see I now have a sheet metal part that is flattenable. And that's what it did, is it gave me a 1/8 inch thick sheet metal part. And you can see if I come in here and I click this radius, it applied my radius that I said 0.1345 as well. And that's key to note later on when we get to our third example of a imported part that already has bend radiuses. Know that the bend radius is something we're going to look at here in a second, right? So that is insert bend when you have imported geometry with uniform wall thickness. So, okay, James, what if the part that I have looks like this? You know, you can see that this is 1/8 inch, but this leg over here is actually 1/4 inch. Okay. Well, can I not use insert bend still? Well, you can, but because the face that I choose as the fixed face has a thickness of 1/8 inch, it's going to completely ignore that other leg. The 1/4 inch thick material, it's not going to do anything with, which is probably not ideal. And you can even see SolidWorks is like, hey, something's not right. It's popping some yellow up here in the model tree. So I'm going to hit Control Z, undo. And instead, what we're going to do is we're going to use convert to sheet metal. So the cool thing about convert to sheet metal is instead of the way insert bend does it, where it looks at what the thickness is already, and that's what it provides you a material thickness for, insert bend allows me to specify what I want that thickness to be, right? And then as well as insert bend, the same way as insert bend, it allows me to put a radius, and I'm going to do the same 0.1345 I've been using. What I'm going to do is I'm going to choose the fixed face, and just like we did on convert to sheet metal earlier in the presentation, I'm going to choose my edges that I want my bends to be. And if I zoom in here, you can kind of see that in this case, I'm going to actually flip the material, reverse thickness, because maybe, you know, we probably want that to be the exact size. And you can see what it's doing. Because I set the 1/8 inch material thickness, it is basically just deleting some of the thickness of this additional leg that was a little thicker. So now when I hit my green check mark and I had keep body turned on, so I'm going to go back and unkeep body. Now you can see I have a sheet metal part that has the bend radius that I need, 0.1345, and it is also flattenable, right? So the third example that I want to talk about was the bend radius already there. I didn't mean to swap back over. There we go. I was like, okay, what if I have an imported part that it is uniform wall thickness, but you can see I have a bend radius already applied. And remember the rule earlier, the universal sheet metal rule, which is my bend radius, which is this inside radius here, should never be less than my material thickness. So that's something that I would have noticed as soon as I open this part, which is this bend radius, and it's going to give me an arc length because it's an imported part instead of a solid model, or instead of a native model. But I can tell you right now that that bend radius is like 1/16 of an inch, which is not ideal because my material thickness, again, is 1/8 of an inch. But because this already has radiuses applied to it, if I try to use insert bend, I click that face, it's just going to tell me no bends found, right? And it's like, okay, well, what if I use convert to sheet metal? And you can. I can choose a fixed face, and I can choose my bends like this. Now it's kind of, there we go. And I can get a sheet metal part. Oh, actually, it's going to tell me no. That's funny. Sometimes it will work and sometimes it won't. But the big thing, let me do that one more time just to see if I can make it work. Maybe I just choose one of these just to show my example here. If I just choose one, that's not going to let me do it at all. But so, like I said, sometimes it will work. But the issue that is going to come into play is when I go convert to sheet metal and I have my bend radius set, it's not going to honor that bend radius on the part that I'm making here. Any new features that I create, it is going to honor that bend radius. So, but the way to really get around this is using the delete face, and the tab I was thinking about earlier was direct editing. Delete face is in the direct editing tab. It should also be in the surfacing tab somewhere. Yep, delete face there, but we'll go back to direct editing. And what we're going to do here is we're going to click delete face, and we're going to look exclusively at the delete and patch option here. And what I'm going to do is I'm just going to choose these radiuses, and then I hit my green check mark, and you can see what it's going to do is it just deletes them. And because I chose patch as well, it's going to add material to give me my sharp corner that I need, right? And, let's do it one more time just to get the inside radiuses. Like here, 3 and 4. And now I have a part that I can come back to the sheet metal tab. And because I can get, yep, okay. I had already created a sheet metal part, so I forgot to undo before I did that. So let's do that one more time. Let's just go direct editing, delete face. I should actually just be able to delete those and make it work there. So if I go sheet metal, insert bend, I can choose that face. And with nope, not going to do it. I will have to delete the other faces. Delete radius, delete radius, delete radius, and number 4, green check mark. And now when I come to sheet metal, insert bend, you can see that it is going to create me a sheet metal part, just like it did in the original example. Sorry for the weird hiccups here. I don't know. SolidWorks is acting a little funky. Okay, so that is imported geometry. The last thing I want to talk about is a section I call Think Outside the Fold, which is just creative solutions using sheet metal features for things that may not actually be sheet metal, right? So the first one that I want to talk about is using sheet metal features on other sheet goods, like anything that comes in a sheet, right? So plywood, HDPE, your various plastics that come in sheet form, you can use sheet metal features for any of those materials. And the big thing there is if you use sheet metal features, it allows for easy exporting to DXF and DWG if you are sending that piece of plywood out to a CNC or out to a router table. And then the last thing that I just want to touch on real quick, and I do have an example for this one that I will show, is using you can use sheet metal features for things like pipe and rod that gets bent. So a common thing, and this is something that we use a lot here at Altec, any kind of like handrail or grab handle, we actually use sheet metal features to create all of these parts. And the cool thing about this is that it gives us the ability to have a flat pattern. That way we can get a accurate, or as accurate as possible, pre-bent length. That way we're not wasting material. So if you don't do it this way, you tend to just kind of have to guess at what the overall length that the pipe or the rod needs to be before it's bent. And you end up typically, you cut it long, you bend it, and then you cut it to size. And this allows us to model it in a way that we can use a flat pattern, and we can get a more accurate flat length, or unbent length of pipe or rod. So quick thing here. So the way that this part was created is that it was created originally with sheet metal features. You can see I have a base flange. It was just a thin feature sketch that I extruded, and then I created fillets to make it look round like a pipe would be. And then, of course, I created the sweep feature to go through because pipe is hollow, right? But like I said, what this does is it allows me to be able to create a flat pattern that when I get into a print, and let's actually use this one because I have a print for this one. When I get into the print, you can see I can put a flat pattern piece on here on the print. That way I can tell my fab shop the information that they need to bend this. So now I can tell them, okay, when you cut this, you need to cut it at 26.64 inches long to get this exact shape, right? And then I can also tell them, okay, from the 0 here, the start of your first bend is going to be exactly 1.5 inches. The start of your second bend is going to be 12.81. And then the start of your third bend is going to be 23.09. If for some reason your shop wanted center of the bend, you could do that too, right? Center of the first bend is 2.53. And, I could go and add those for the other bends as well. So that's the cool thing about sheet metal features, or sheet metal in SolidWorks, is you can use it for things that aren't necessarily sheet metal, right? Anything that is sheet goods, or even round pipe stock, round stock, stuff like that can also be utilized.